In modern warfare, artillery is no longer just about volume of fire. It is about reach, survivability, and the ability to strike precisely, then disappear before the enemy can respond. Since 2022, the war in Ukraine has reshaped how militaries around the world view long-range fires. Highly mobile rocket artillery systems capable of engaging targets dozens, even hundreds of kilometers behind the front line, have become central to shaping battlefield outcomes. It is in this context that Russia began accelerating the development of a new generation multiple-launch rocket system, known today as the SARMA 300mm. Developed by Rosoboronexport between 2022 and 2025, the SARMA was conceived as a response to the changing realities of modern high-intensity warfare. Early operational lessons highlighted the growing importance of precision-guided rocket artillery, capable of striking command centers, ammunition depots, logistics hubs, and air defense positions well beyond the reach of conventional tube artillery. Russian forces already operated legacy heavy rocket systems, but many were mounted on tracked chassis or optimized for area saturation, rather than rapid precision engagement. SARMA represents an attempt to adapt to these evolving demands by combining heavy caliber firepower with enhanced operational mobility. At the center of the system is a launcher mounted on the KAMAZ 63501 8x8 military truck chassis. This wheeled configuration fundamentally changes how such a system can be deployed. Unlike tracked launchers that require transport or careful logistical planning for long-distance relocation, SARMA is capable of moving rapidly along road networks, deploying into firing position, launching its rockets, and relocating within minutes.
The SARMA 300mm MLRS is the further development of the 9K515 Tornado S system, with accuracy and maneuverability prioritized. The SARMA MLRS is capable of engaging a wide range of targets, including motor rifle, tank, artillery and rocket artillery units in operational areas, air defense and missile defense systems, electronic warfare units, and sensitive logistics and command and control assets. For instance, command and control posts, communications hubs, ammunition depots, etc. The system incorporates 5 main components: the SARMA MLRS, 300mm guided rockets, the SARMA fires 300mm guided rockets with various warheads, as well as unguided munitions for the SMERCH MLRS. These guided rockets have very high accuracy and are capable of engaging, depending on their warheads of course, almost any target on the battlefield, ranging from tanks and field fortifications to air defense systems, long-range artillery, and command and control assets.
This shoot-and-scoot capability has become increasingly important in a battle space dominated by counter-battery radars, surveillance drones, and precision-guided return fire. Remaining stationary for even a short period can expose artillery units to rapid detection and destruction. By emphasizing speed of deployment and redeployment, SARMA is designed to operate in dispersed formations, reducing the likelihood of detection while maintaining the ability to conduct coordinated long-range strikes. Its primary armament consists of 300mm rockets, significantly larger than those employed by many Western-wheeled rocket artillery systems. Depending on the type of munition used, SARMA is reported to engage targets at distances of up to 120 kilometers. This allows it to strike deep into rear areas, potentially targeting infrastructure that supports frontline operations, without exposing the launcher itself to direct enemy engagement. The large rocket diameter also allows for heavier payloads. Warhead options may include high explosive fragmentation, thermobaric effects, or specialized submunitions designed to disrupt formations or damage hardened targets. In operational terms, this means that each individual rocket carries a potentially greater destructive effect, enabling fewer launchers to achieve comparable battlefield impact against high-value targets. Comparisons between SARMA and Western systems, such as the M142 HIMARS, have become increasingly common. HIMARS employs 227mm guided rockets and has demonstrated its effectiveness through highly precise engagements at extended ranges. SARMA, by contrast, appears to emphasize heavier caliber munitions capable of delivering greater payload mass over similar distances. While HIMARS focuses on precision integration within digital targeting networks, SARMA reflects a different balance between mobility, payload size, and strike capability. These differences illustrate diverging operational philosophies. One approach prioritizes lightweight, precision-guided munitions supported by advanced targeting infrastructure. The other seeks to combine long-range engagement with heavier warhead delivery in order to increase destructive potential per strike. Both concepts aim to achieve standoff engagement of critical targets, but through different technical pathways.
The system fires guided rockets with various warheads at distances of up to 120 kilometers, and unguided rockets at ranges of up to 90 kilometers. The SARMA is mounted on the KAMAZ 8x8 all-terrain truck, which features armored crew cabin providing protection against 7.62mm armor-piercing bullets and fragments of artillery rounds. The vehicle is fitted with an advanced digital fire control system. High transportability and operational theater deployment capability of the SARMA MLRS are worth emphasizing. Having a gross combat vehicle weight of about 28 tons, the system is rather mobile and provides a cruising range of 1,000 kilometers and a maximum road speed of 95 kilometers per hour. The SARMA can also be transported by any type of railroad, maritime, and aerial transport.
SARMA's first public appearance at the World Defense Show 2026 marked its transition from a developmental program to an export-oriented platform. Presented as a mobile long-range strike solution, the system reflects broader trends in modern artillery doctrine, where mobility, survivability, and precision are increasingly valued over sheer volume of fire. Within the context of the ongoing conflict in Ukraine, systems of this class demonstrate how long-range rocket artillery continues to influence operational planning. By enabling strikes against supply chains, command infrastructure, and staging areas beyond the immediate battlefield, such platforms contribute to shaping the tempo and depth of military operations. Ultimately, the SARMA 300mm MLRS highlights Russia's effort to modernize its rocket artillery forces for a conflict environment, defined by rapid detection cycles and long-range precision threats. By combining a heavy-caliber rocket system with a wheeled, road-mobile launcher, it represents an adaptation toward greater flexibility in how long-range fires may be deployed in future high-intensity engagements.